Okay, so let's start. Welcome everyone once more. Today we're going to talk about the 12 factors. Have you heard about the 12 factors from Hiroko, the methodology? Okay, so that's the idea. We will talk about that. We will introduce and go through each one of these factors. My name is Rafael Benevides. I work for Red Hat for more than 7 years. I started in Brazil as a consultant. Then I moved to a software engineer role. And now I'm living here in the US for 2 years, working as a director of developer experience. My background, essentially I'm a Java developer, okay, but given that DevOps practices are so popular nowadays, I'm also very involved with containers. Let me know a little bit more about you. How many of you are developers? Raise your hands. We have a few developers here. And how many of you are operation people? Oh, good, the most majority. So welcome everyone. And the idea of this practice are very focused on development, but for people who are from operation, I think that it's good for you to understand those practices, because that could help you to work together with the developers on your company and help them to produce a better software that will run in the cloud. Okay? Before starting this talk, I want to invite everyone here to join the Red Hat Developers Program, which the URL is developers.redhat.com. There you can find valuable resources for development, not only for developers, because there you can find free access to Red Hat products, you can find free ebooks, blog posts, and in the near future we hope to have webinars as well. But let me tell you a story that happened to me when I was in Brazil. One day I was there in a weekend with my niece. She's a child of 4 years old on that time. She's now 6. And we were walking in the zoo of in the city that I lived, Brasilia. And she's crazy about superheroes. So she went to a cage, looked at an animal, then looked to another, and came to me with a tricky question. She said, well, I've realized that every animal has a superpower. The monkeys can climb the trees very fast. The snakes have their poison. The birds can fly. And she asked me, what are the human superpowers? And that question made me stop for a moment and think what should be the best answer to that 4 years old child. And the best thing that I could think in that moment was to say that thinking is the best superpower that we have. Because thinking has taken us to places that we never imagined before. Thinking has made us to become problem solvers. Of course, until we decide to become programmers or people from the IT industry, right? Okay, that's a joke. But what happens when we identify a problem? Since we are problem solvers now, the first thing that we do is identify a problem, and then we start to analyze that problem and try to find the best solution, analyzing the cause and effects to solve that problem, right? And once that we have all the different scenarios, how we can solve that problem, what are the impacts of that solution, we come with the best solution for that problem. But it doesn't stop there. Once that we have what we think that's the best solution, we kind have a continuous improvement loop. We start to think again if we have an improvement of that solution, right? Who was here yesterday in my talk about deployments? Cool. I talked yesterday about the feedback loop. And here, to solve a problem, we face again the feedback loop. And talking about the feedback loop is so important for us, for human beings, and also for people who work in the software industry, because let's think, when we are learning how to talk, we depend on the feedbacks of our parents to know if we are using the right grammar, if we are pronouncing the word in the proper way. When we are learning how to walk, we depend on the feedback of the gravity to know if we are walking the way that we should walk. And to solve a problem or to produce a software or to find a solution is the same way. We depend on the feedback from someone, from a solution, from a personal analysis of the cause and effect to come with the best solution, right? And once that we have a solution, what do you think that it should be that we should do with the solution? Any guess? We should share, because once that we share, we have more people joining the feedback loop. When we share, if I find a solution, I think that's the best one, but when I share that with you, you might say, have you thought about that perspective? Have you thought about that another impact? So share is something so important for us because we can have more people joining this feedback. And when we share, we become stronger, okay? And that was what happened to Heroku. Because Heroku is a cloud provider company, and they host several applications in the cloud, and they realized that more or less they kind of have, their customers kind of have the same issue when they decided to release their application in the cloud. And for the most majority of their customers, they realized that the solution was more or less the same. So they decided to collect those solutions and create a methodology of that they decided to call 12-factor. It's hosted in this website, 12factor.net. And it's composed by 12 practices to help produce better software and deploy that in a cloud environment. So what we will do today is a kind of journey through each one of these factors. Okay, we don't need to memorize them, but we need to understand why it matters, why it's so important. Because if we take a look on these names, we will see that they have odd names. It's not very trivial to understand what they are saying and what problems they solve. But we need to understand, and we don't need to memorize, but we need to understand what are the impacts if we don't follow these practices, okay? So let's start by Codebase. Each factor has a title, has also a brief description, and sometimes it has an image. So it was copied from the website, for example, Codebase. One Codebase tracked in a revision control many deploys, and it has this image. But what does it really mean? It means that we should use a version control, okay? But we should use a version control the right way. For example, I will not only talk about these factors, but I will also use an application that I developed, and I tried to make this application as close as possible to the 12 factors, okay? So Use version control. It means that each application should be stored in its own repository. That application will be packaged, and then we will make one or more deployments of the same application. We will deploy that in a development area, we will deploy that in a staging area, and finally that application will be deployed on production. But what it does not mean, what you should not do, I've seen some companies that, for example, they have an application that evolves fast in development. So they store that code base in a repository. And they have a stable release that's running on QA and on production. But sometimes, when it's running on production, they find bugs, they find security issues, and they decide to update that version that's running on production. And they usually do that in another repository. That's a problem. You should avoid that, because the software that you are evolving, the next version that you are developing, will not have those fixes. So you should avoid having separated repositories and store everything in the same repo. But how you can control that? Using separated branches, okay? Another thing that I saw in some companies, and you should avoid, is having the big master repo for everything. Every application will be on the same repo, including the documentation. So please avoid that, because every application has a different story. It has a different release. You release a tag of that repository, and if you are releasing a tag, you are releasing everything that's inside. Sometimes that can be true for documentations, but they have different evolution process. The documentation should evolve in a separate way, in a separated way from your application, because sometimes you can find a typo, you can find something that you didn't cover. So it's preferred to have a separate repo, even for the documentation. The application that I use to deploy here is hosted on GitHub in this URL. You don't need to worry about that, because what I want to show you is that my single application is hosted here. Okay, I don't have any other application. Of course, I have a bunch of scripts that I use to demo each one of the factors. But the point is, once that I release this application, the same code base will be used in every other environment, in the development, QA, and production. Okay, so let's keep moving to the factor number 2, dependencies. The title is Dependencies. It says in the brief description, explicitly declare and isolate dependencies. But what does it mean? It means that you should never store dependencies. For example, for Java developers, you should not store jar files inside your repository. If you are using, for example, Node.js, you will not store the node modules folder inside your repository. Nowadays, every modern language has your own package management system. For example, Node.js has NPM, Java has Maven, Ruby has the gems. So the idea here is that you should declare your dependency, and that will avoid binary conflicts, because that's not the dependencies, the binary dependencies are not stored in the repo, and you can track the changes from one version from another. So for example, this Java application here, I have a pom.xml, which is the Maven file of Java. We can take a look on this XML that has the definition. of my project. And here you can see the dependencies explicitly declared. So, for example, I have here the common slang version, I have here the MySQL driver, and I'm using a Vertex toolkit to build this Java application. So the Vertex version is declared here as a property. Okay, if I need to update this version, once that I update and I commit and I submit a change to the POM.xml to Git, I will be able to track who changed, why it changed, when it changed. Okay, so that's the purpose of dependencies. But now let's take a detour to the factor number 5. Then we will return to the factor number 3 and 4 later, okay? Because it makes sense to explain those factors that way. Because the factor number 5 tells us about build, release, and run with a small description saying, strictly separate build and run stages. But what does it mean? It means that you will, each stage, each step of your until you have your source code and have the application running on production, you have a different step. For example, the first stage, build the application. What you will produce? In the case of a Java application, you will produce a WAR file or a jar file, okay? Usually this step is performed by a CI tool, like Jenkins, for example, because we want to avoid people saying, oh, it works on my machine. That's very common when you take a package that was built on the developer's machine, it has all the dependencies, and you throw that on production. Sometimes the environments are different, so or you don't have all the source code. So to avoid that, please use a continuous integration tool like Jenkins. Then we will release our application. But nowadays, we are talking a lot about containers. So what we will release? We will not release our WAR file or jar file. We will release a container image. And we want to release a container image because with containers, it's easy to do deployments, it's easy to scale, it's easy to do updates and even rollbacks. Okay, a release should be able to, should allow us to perform rollbacks, okay? And something very important, every release should always have a unique ID. And with containers, that's true, because when we are releasing an image, every container image has its own hash code, okay? So we can use that hash code as an identifier of a release. And finally, once that we have a container image, what we can do, what's the next step? We will run an application on a platform that's capable of running containers and capable of orchestrating containers as well. Okay, because we want speed, management, orchestration, and what I will do now is execute, build, release, and run this application inside OpenShift. Okay, of course, when we are talking about CI/CD pipelines, when we are talking about continuous integration and continuous delivery pipelines, all these steps should be performed inside the pipeline, okay? They are different stages of the same pipeline, okay? But the idea here is that you will not mix one thing to another because they are really separated things, as I will show you. So I have already my application here cloned from Git. Just to start from the scratch, I will do a Maven clean, which will clean my environment. So I don't have any binary here, okay? What I will do is build my application. This is just a Maven command that will use all the dependencies that's declared inside that POM.xml and produce my binary. Okay, now I have my binary here, my fetch.jar that it was just built. Now, the next step is what? Is release. What I will release a container image. Since I'm running OpenShift, OpenShift already provides internal registry for our image. Okay, I have here a place to store that image. And when I do the release, it will get all my resources. It will get my Docker file. It will get my fetch.jar, my binary. Will send to OpenShift, and OpenShift will use that Docker file to build the image. And once that the image was built, it will push to the internal registry. And at the end of the push, you will see here the latest tag that was created a few seconds ago with the hash ID. This is the release, the ID of this release, okay? Because even if I don't change the version here inside my POM XML where I have my definition, for example, I'm here saying that the version is 001. Even if I don't change that and perform another release, if I change anything, that will cause the image to have another release ID. So we know that something changed from one version to another, from one image to another, okay? But my application is not running yet. I just have the image released inside OpenShift. And what I will do now is ask OpenShift to use that image and run my application. So OpenShift will create a deployment of that application. We can wait for the application to become available, and we can test it. Okay, the application is running. Let's open here. API, hello, R8 Summit. Hello, Red Hat Summit from this application. Okay, so that's really easy. And let's continue with the factor tree. Let's go back to the factor tree. The factor tree says config, store config in the environment. But what does it mean? It means that if you need to change anything, to change anything in your application, if you need to repackage, you are doing something wrong. Okay? That's true, for example, for database connections. If that's hard-coded on your application, and if you need to repackage that because you changed the host or the URL of your application, you're doing something wrong. You should store that outside your application in the environment, and that could be environment variables, property files, configuration files, but again, if you need to repackage, you are doing something wrong. And how we can demo that? For example, I will change the behavior of this application. I will insert an environment variable here that will, when I insert a new environment variable, OpenShift knows that the previous container doesn't have that. It needs to create a new container that contains the environment variable. It will perform a rolling deployment. And this new container, we can take a look, we will see an environment variable called greeting with a new pattern for the greeting message. Okay? If we refresh our application, we see that the behavior of the application changed. But again, I changed the behavior of the application, but I didn't repackage or re-release my application, okay? So let's continue to backing services. Treat backing services as attached resources. The idea here of this factor is that you should be able, for example, to have a MySQL, for example, this application is connected to a MySQL running on-premise, and tomorrow for any planning or for any strategy, you decide to move that to a MySQL running in a data center. or to run MySQL running on the cloud. You should be able to do that because your application is not really attached, is not tight attached to that resource. You should treat that as attachable resources. The same is true for volumes, for example. You get used to store the logs on a file system, and then you decide to move that for an NFS storage. You can change the volume. Or, for example, you are consuming a service from Twitter. You should be able to do that. And the way to demo that is, for example, I will release an application inside OpenShift. But this application here have its own host because it uses a service that I defined with the name MySQL. Okay. My application needs to know where is the host name, even if I'm using Kubernetes. It also needs to know about the username and password. So I'm attaching a resource using the factor number 5, but I'm also using here the factor number 3 to define new configurations for this new container. I have the definition of the host, I have the definition of the password and the username as environment variables. Again, I could use proper files, I could have use any kind of cryptography, but since this is just a demo, the configuration is available in the environment. Now that the application is running, I can open another endpoint. I will see an error because my database has no data yet, but I will populate my database just to show that if I refresh, I have my application connected to that resource. Okay? So what about the factor number 6, processes? I've talked yesterday about processes when I was talking about deployments and not sharing state. In fact, if we think about that, every application needs to store a state somewhere, okay? And the right place to store state is on those backend services, okay? The idea here is that you should never store something inside the container. You should never share something because that could cause a problem when you are doing a deployment or when you are updating from version 1.0 to the version 2.0. Okay? Of course, when we are talking about RESTful endpoints, that's very trivial, okay? As you can see here, this is a REST endpoint with no state, but I should be able to perform in the deployments with no state stored. If we are talking about HTTP session, we could use JBoss data grid, a JDG, as a backend service that I will attach to my application and send every state to there, okay? So what about port binding? What does it mean? Let's think for a moment what happens with containers. When we run containers, even if we do a Docker run, for example, use capital P to expose every port and run my application demo 1.0. Okay. This application internally use port 8080. Let me cancel that and run as a detachable resource. Okay. and do a Docker PS, I have a mapping between my external port and my local, and the port of my container, right? So you can see here that I have a mapping between 32782 to the port 8080. Of course, I could specify the port myself, but that will affect any scaling, because if I want to run more than one container on this machine, it will complain about the port. Or sometimes, if imagine a situation where you have a MySQL running on the port 3306, and your application or your sysadmin says that you need to deploy another MySQL, and you don't have another interface, or you don't have another server, and he says, okay, I will deploy MySQL on the port 3307. That could cause a problem to your application. So the idea here is that you should never depend on the port, because when you are, I showed to you, sometimes container provide the port to yourself, okay? And for example, even Java applications, sometimes they are running on the port 8080, and you want to connect using the port 80. The way that you know the proper port, again, is using what you learned as the factor number 3, is using configuration to know the proper port. So what I will do now, you can see that my SQL service is running on the port 3306 with the target port to 3306, and I have the connection, everything is working. And I will change the port to the port 5000. Okay, you can see that a new port 5000 now is mapped to the 3306. And my application now has another configuration with a factor number 5, the factor number 3, that says that the proper port is 5000. So I changed the port, and to show that, let me do something else. Let me come here to the MySQL service, and I will just remove the mapping of the port 3306, just to show that my application will continue to work. Okay, so I'm not really attached to the port. What about concurrency? Concurrency says that should scale out via the process model. I like to say that this is the best advocate for microservice. Because suppose that you have an increase on sales, or you have an increase on the finance model of your application. You should be able to scale just that part that requires that you scale up or out your application. You should never scale your application completely. And the only way to do that is if your application is divided in small services, microservices, or modules, or remote or distributed system. Okay. So using OpenShift or using containers, it's easy to scale, because I could simply say, please scale my application to 3 containers. And you will see that now I have just one, but once that the containers start, I will have more 2 answering the request on the same route. Okay? And that also matches with the stateless process, because now I can see that I have I have a request being made, and my reply being responded with no state. Okay. So to scale application, I can even use the UI to scale up and down my containers. So I have now 4 replicas. I can scale back to 3. And that's so easy to do with OpenShift. Now let's talk about disposability. The best way to explain disposability is with the theory about pets versus cattle. Most of you are sysadmins, so have you heard about this theory, pets versus cattle? So let me explain for those who never heard about that. For many, many years, we treated our servers as pets. Okay, we give them names. If they were sick, we took them to the vet, right? I've seen funny names for servers. I've seen servers using names of planets, names of philosophers, and that's funny because one day I arrived to work, in my work, and I saw the sysadmin literally crying, and I asked, what happened? And he said, oh, Plato has died. And I thought that he was talking about his relative, but he was talking about the server. So he was really emotionally attached to that server. But the idea of the 12 factors is that we should treat our servers just like cattle. Because if the server dies, we can just replace it by another one. It doesn't really matter the name. We simply should be able to start fast and replace it fast. And that's also something that we can do with containers. Because, for example, let me kill some processes here. I have 3 containers, and I destroyed 2 of them. Okay. OpenShift knows that I want to run 3, so it will detect that 2 of them died, and will automatically start 2 new instances to fulfill that request. Okay, so now I have everything running again as in the beginning. 3 instances replying my request. So I can even do that again because it's so easy to do. The name of the host doesn't really matter. What's important here is that I was able to replace those containers. Okay. So process can be started and stopped at any moment. Process should minimize startup time, shut down gracefully when they receive site term, and should also be robust against sudden death. So that's what about disposability. What about dev to prod parity? Keep your development stage and production as similar as possible. Of course, this seems to be so trivial, but even so nowadays I saw some companies performing deployments physically. They take the application from the developer machine and send that to the production. They copy that to a folder. And what we should do to avoid that is use a continuous deployment pipeline where the developer will not send anything directly to the production. It will send to a Git repo, to a source code repository. Then something else, the CI/CD tool like Jenkins can get the source code, build and package my application, perform the deployment, and that deployment will suffer every kind of tests, integration tests, stress tests, unit tests, to finally have that release on the staging. And if it's okay in the stage area, then we will move that package to the production. But the idea here is move the package. So I have my application here running on the development area. You can see that because I have -dev. Okay. Let's recap the name of the image. The release ID is F9B0. And what I will do is perform a deployment in a staging area. Okay. Again, with containers, I have already released my image, so I don't need to release my image again. If we go here to the staging and take a look on the image, we will see that the image is the same that we released in the beginning of this session. Okay? So the application that's running here in my staging area is the same one that we produced on the development area. We can even try my application, and it's the same. Okay, any parameter that I use here, what is important is that my application is the same that I released. So let's move to factor 11, logs. What about logs? It says that we should treat our logs as event streams. A 12-factor app never concerns itself about routing or storage of its output stream. With containers, that's already true, because we can even do a Docker logs, for example, demo1, we will get the logs as streams. We can come here to OpenShift and use open the terminal. We will see the logs being produced. We can use OC log, for example, OC get pods, and OC logs, and a name of a pod, for example. We will see the stream of the log. If you need to store the log for any analysis, you should have something else that will collect that stream and perform any kind of analysis. Just like ELK stack, Elasticsearch, Logstash, and Kibana, or Elasticsearch, FluentD, and Kibana. Okay? If you want to use any kind of auditing tool, that's also something that will consume that stream. But your application will not worry about storing. Just produce the log, okay? So 11 logs, we can see that. And finally, we will see the factor 12 called admin process. We all know that containers already run just one process. If we take a look on the PID of a container, we'll see that the PID number 1 is the process that we started. In this case, it's a Java application, so I have Java running, plus my shell and my PS process, okay? But the idea here is that, suppose that I want to perform a maintenance task. If we perform that maintenance task using the main process, we could eventually have an increase of CPU usage or memory usage. So you should try to avoid mess as much as possible with the main process. You should be able to connect and use an admin process. Of course, sometimes that admin process will have to communicate with the main process. But if something frees, you can just kill the admin process and never kill and never mess with the main process. Okay? So for example, one way to demo that is opening a new process in this container. I have the main Java process. I can open a shell here that will give me access to that console. And of course, I can perform any kind of task here, avoiding to have anything that will impact the CPU and memory usage of the main process. So that is the idea of the 12-factor. It's not focused on any technology. We can apply that in any language. We can apply that to PHP, Python, Java, Node.js. But we can satisfy all those factors using containers, as you could see during the whole session, with microservice and CI/CD pipelines. It's very focused on DevOps practices, and as you could see here, the factor is stored. You can see the details in the page 12factors.net. And if you are curious about the demo that I've used, the demo app is stored on this GitHub URL. So we are open to questions now. If you have any questions, please feel free to. Okay. So by the way, thank you so much, people. And the question was, The 12 factor is not attached to a specific technology, but the factor number 11 tells us about the logs. And the logs is produced, I could consume that with OpenShift, as I presented here, okay? But I have also presented how I could consume the log using raw Docker command. Since I'm using containers, the idea here is just get everything that's produced inside containers. But the point is, this application, I have 3 replicas running. Okay? And sometimes I need to analyze what's happening to every one of them. So the best way to do that is using a kind of tool like Logstash, Elasticsearch, and Kibana, because that will aggregate the containers of these 3 pods. Sometimes I have more than 3. I have 100 of them. It's something outside of OpenShift. But again, all those tools consume streams. It doesn't consume files. Oh, of course, some of them can consume files, but the idea is to be lightweight as well. You don't need to concern about the storage. Let's see more details. What it says here on logs. Splunk, yeah, such as Splunk, exactly. So the event stream for an app can be routed to a file or watched via real-time tail in a terminal. Most significantly, the stream can be sent to a log indexing and analysis system such as Splunk. Yeah, that's true. Or general purpose data warehouse systems such as Hadoop Hive. So that's the idea. You're welcome. Any other questions? Well, we are out of time. Thank you so much for your presence here. Thank you. And the slides are available in this URL.